So, approach to structural engineering. Being a structural engineer, I would be discussing in the line of structural engineering instead of the overall engineering consultancy services. So the first question comes up to mind, what is a structure? It may be in layman's term, structure is defined as anything constructed or erected with fixed location on the ground. And that's what any normal people would understand. But in structural engineering terms, what does a structure mean? It's basically a geometrical shape which provides paths for implied loads and is capable of elastic deformation. Why do I call that it provides a path for implied loads? The basic idea for a structure provide a geometrically aligned shape which would carry out some load. Force is a term which can be understood as that force flows through the structure, and it flows from lower moment of inertia to the higher moment of inertia. That means from a less stiff part of the structure to the higher stiffness, right? That's why we generally, before even going into in-depth of engineering, structural engineering, we see that all the forces are being dumped into the foundations. For what reason? The foundation is the rigidity that a structure derives. So the force from the entire structure, from the top and the middle layers and sides and everything, that gets dumped into the foundation because it needs to flow through its geometrical shape without distorting its shape too much and gets exerted into the ground. Basically, the dissipation of energy. So the next question that comes up to our mind, what is expected out of structural engineering? So some brief about what is expected you might have understood from the previous slides. Now I'd be a little bit more specific. All right. So first thing is when you take up a new project as a civil structural engineer, you need to understand its feasibility and utilities of the structure. What do you mean by feasibility? I mean, feasibility means basically the location of the structure. I mean, where exactly it is located. You may need to build a structure which is going on top of a railway line, or you may need to build a structure which is right adjacent to an existing structure foundations, or in between cluster of small buildings, you need to put up a new structure, or you might need to provide a new structural solution on top of an existing structure. So you need to understand the feasibility of a structure and how it has to be built. Then you need to devise a solution for it. And then you need to understand the utilities of the structure. So what the structure would be servicing for. All right. So there could be a structure where numerous amount of public entrance is required, or it serves to a large crowd. That would be a serviceability of the structure. Or a structure could be just housing a couple of pumps, just a little shade. Or it could be a structure where heavy equipment, crushing equipment, moving equipments are being loaded, and it needs to move material from one place to another, or crush material, or transport material. So these are the utilities of a structure that comes up during the initial phase of a structural engineering. And accordingly, one has to understand the loads that would work, ideas for loads that one might get from Indian standards, that is on IS 875 part 1 through 5. Next, on a structural engineer's expectation comes understanding the serviceability of the structure. We did understand what utilities or what sort of requirement a structure needs to fulfill, but for how long is also a main criteria for starting in structural engineering for any structure. And the code suggests for 25 years, 50 years of serviceability, and accordingly, there are important factors that needs to be accounted for engineering solutions. And after these two initial points, you need to come up to a solution for engineering iterations. What sort of solutions that you might consider? Say, for any concrete structure, you might not want to go for any steel building over there because concrete and steel interacts differently with horizontal forces. Horizontal forces include, wind and seismic, and other dynamic forces such as dynamic equipments and stuff. So where concrete is needed, where steel is needed, where both are needed, these sort of solutions plus a solution based on the geometry and the feasibility of the location, solution based on where exactly need to be built. Like, say, I mentioned that if you might need to provide a structure which is basically built on top of a railway line, then how much of a gap, how much of an opening that you need to provide for a locomotive to pass beneath your structure. The sort of solutions that you need to come up before going into your engineering applications. Then the things become a little streamlined, performing the load calculations, the analysis, whether you want to go for elastic analysis or period and pushover analysis, all those sort of things that comes after these sort of considerations one engineer have taken and noted down and went on with their analysis. And the last and but not the least is reflection of your analysis results into a deliverable. What do an engineer make? An engineer makes a drawing. He creates a drawing which is basically an engineering way to represent his results, his understanding of the analysis. Preparation of engineering drawing, I know all of the participants have had certain exposure into engineering drawings. I certainly did when I was in your age and had the exposure of manually drawing on a big, large paper. In this case, the same thing has to happen. Whatever you have analyzed, building, structure, foundations, that needs to reflect in your drawing. Okay, we'll move on to the next bit of slides. In recent time, what are the softwares that help us do the analysis and the drawings? So the widely used engineering software that comes up straight in front at the top is STAAD.Pro analysis. It's a great engineering software for plant-based structures, stick framing, and equipment supports as well. I would like to show one of those pictures so the recent version of STAAD.Pro looks something like this. It's called the STAAD.Pro's Advanced, where you can see that this structural arrangements which move material from one end to the plant to the other end of it. And this is just one part of a gallery that required analysis, basically the user interface of recent STAAD.Pro. We'll switch back to my presentation. Yeah, the other softwares, engineering softwares that comes up into mind is ETABS. ETABS is a great software which is highly used for high-rise buildings, commercial buildings, engineering. It's great for AP analysis, and I myself have used ETABS in multiple locations. SAFE is another software which is predominantly used for flat slab and foundation designs. Excellent software for AP analysis. SAP 2000 is also another software which is basically similar to ETABS and but has a lot of application for dynamic analysis on equipment foundations, as well as it could be used on structure design as well. Then there's RAM structures, which is a very recent software from Bentley. Bentley also produces this STAD Pro software. And then you have your own hand calcs and worksheets, which will always have helped us along the way. So there's one little snapshot of how a hand calc looks, and I'd quickly share that with you guys. So this is a basic of foundation design engineering, and I will come to this once we're at the end of our slides explaining. Then there are 3D modeling and design drawing softwares, which basically involves most of our consulting engineering companies use AutoCAD 2D and AutoCAD 3Ds. You make drawings on that, and 3D also helps us, and capture the three-dimensional isometric views of any structure. Tekla Structures, which is one of my favorite 3D modeling softwares. It is extensively used for fabrication and shop drawings, and it is pretty detailed, and other softwares would include Revit and S3D, PDMS. These are also pretty advanced 3D modeling software. Well, once we have done this 3D modeling, then comes a question of 3D review softwares. Otherwise you would end up messing up with other departmental items, such as pipes clashing with each other or electrical wiring going haywire. So we have 3D clash checking softwares which generally used these days are AutoCAD Reviewer, PDF Viewer, Navisworks, Revit. Again, Revit, SP3D, and PDM. All these you can use as modeling and design as well as clash checking. Let me walk you through this particular one, this Navisworks, because I have it opened in my computer, and explain you one of my projects that I have recently concluded, that how a clash checking is done and how a plant is looking after it is entirely engineered and modeled. So basically, this is a plant in the United States, and it is an extension of existing facilities into a new facility. All right. So we can see the difference between color, and I'll slowly move inside and share you. Okay, so one of the first structures that comes up in the new facility is a very humble pulpit structure. So this is called a pulpit, which is basically a control room, and it houses, it's basically a modular structure which comes as a whole and sits on top of this steel structure that sits beneath it. So this pulpit has some piping and some wiring and multiple steel structure and framing that goes all around it. So we need to, as an engineer, we need to understand where each facilities are moving and how it is moving, and figure out a way to provide a better structural solution, such as this. This pipe is slightly going inside. I have intentionally put it inside just so that we can explain what is going on. So this pipe comes from either mechanical or electrical department, and I, as a structural engineer, need to provide my steel in such a way that I have to either provide a better support or completely avoid the pipe. So the similar thing have been done right at the bottom. If you can see that these pipes take support from these two columns, and they are supported in such a manner that they are routed in such a manner that it avoids my steel column and takes a proper support from this. A little basics on how a clash check may be resolved and needs to be checked from time to time. All right, moving back to our slide. And finally, coming up to connection design softwares. We do have a certain connection design requirement for steel structures, connections for steel beam to column or beam to beam or steel column to concrete pedestal. So these sort of things can be done by the help of RAM connections and Hilti Profit software. And I will show one of the pictures that I've taken from RAM connection design, and I'll share my screen. This is how a RAM connection user interface looks like during a base plate design. You can see that one need to provide column size of the base plate, and anchors and grout, and if you want to use shear key and all. So these sort of details come into picture during a design on the base plate. All right, moving on, we'll go to our next slide, which is foundations of a structure. So this is where we discuss a little bit on foundations, and this is the first stepping stone of building a structure. You need to provide a foundation in order to build a structure on top of it. It's very simple. So what is a foundation? Well, in a structural engineering term, a part of the structure by which above ground structural load is transferred, energy dissipation, as I discussed earlier, to the bearing strata of soil. All right. So two things that we need to be careful in understanding this term, in understanding this line, basically, is that load transfer and bearing strata of soil. All right. So during studying a geotechnical report will provide us with suggestions on what strata, what depth of soil that one needs to go down in order to found a proper foundation. Okay, a geotechnical report can suggest different type of foundations, basically. So it could be a shallow foundation, or isolated or mat foundation. It could be a deep foundation, which could result into piles, or it could have soil improving techniques, which would require micro piles, where you would need all these suggestions. One need to understand before selecting a soil strata for founding their structural foundations, and come up to a certain depth. And then the geotechnical engineer or the report would suggest a bearing capacity as well. So once we understood the geotechnical report, then comes the type of foundations that you want to select. So a general classification of foundations can be made as shallow and deep, as I discussed a little earlier. Shallow foundations, you've already read all these things during your engineering years. These are isolated, combined, and mat foundations. Deep foundations include, pile foundation, which could be made out of isolated or combined pile caps, I beg your pardon. And then there are piled rafts. These are very basic differentiation between shallow and deep foundations. Other than that, there are different specific required foundations for, say, pump foundation or a turbo generator foundations or a crushing mill foundation. All these are equipment foundations which require dynamic forces to get dissipated into soil. So, and other types would be general equipment foundations. Stack foundation. Stack means chimney, and grade foundations. Anything that is resting on top of basically grade slab, which is a slab on top of engineering filled soil.